Once my teacher told me that whenever there is a flow of the water through the pipe like this, the different cross-section, let's consider it as the velocity of the water through this as VA, and here it is VB. Then she told that the VB is greater than the VA. Yeah, then I say yes, that's true, because the water flowing through this has a larger the volume. That's why in order to maintain the same amount of water flowing through both the pipe at the same time, then the velocity of the region A should be greater than the velocity of the region B. Sorry, the velocity of the region B is greater than the velocity of the region A. That's true. And she say one more thing. That's blow my mind. Like if the pressure of the region A as PA and the pressure of the region as B as PB, then PA is greater than PB. Then I just wondered why. Because if I place my hand here, I feel more force from the water exerted to my hand than when I place my hand here. Then how it comes? How the pressure of PA is greater than PB comes? I asked the doubt to my teacher and she told me that, what do you mean by pressure? I just say that pressure is something that the force exerted per unit area. It is actually the force per unit area. Yeah. Then she told me that in this case we are considering how much force the fluid exerted on the wall of the container. Then I just think that yeah, that's true. The force exerted on the wall of the container should be different. But how can we think? How can we imagine that things? Let's imagine that things. I'm taking the pipe with the molecule as a small particles for easy calculation, and let's look at there what's just happening there, what's just going on there. If we take a small element from the A, the water molecule, it is our water molecule baby, and if we look at this water molecule, we can see that it has a velocity in this direction as VA. That's velocity in the x direction. And if you take the small water molecule maybe of the B, it also has a velocity in the direction as VB, x direction. And if you look at one more thing, that here the kinetic energy is a constant. That is, the kinetic energy of A is exactly equal to the kinetic energy of the B molecule, because the average value. Because we can see that how much height is increase the pipe, that much height is decrease the pipe. That's why the potential energy is a constant. So the kinetic energy of the both molecules should be same. So if VB and VA we have taken, we know that the VA is lesser than VB. VA, let me check it. VA is lesser than VB. That means that the water molecule of the A, which has the x component, is lesser than the x component of the VB. And we know one more concept is that the velocity will be equal to Vx square plus Vy square plus Vz square. So if Vx square is lesser, very lesser, then if the energy if the velocity need to be same, the Vy should increase and Vz should increase, which are both perpendicular to the Vx. And we are more considering the perpendicular components, which gives the pressure, which gives the momentum to the wall of the container, which gives the pressure. And here the VA is lesser than VB. That's why the Vy and Vz component of the water molecule A is greater. That's why it should exert more momentum to the wall of the container than the B molecule. That's the concept. That's why the pressure exerted by the VB will be lesser, as we calculating, than the pressure exerted by the VA portion. This blows my mind. I never think so. These things will happen in a fluid. If you imagine just simply, we will see that here the A portion there is more velocity. That's why there is more force. So there is more pressure. But that's not the story. That's just a wrong imagination.